Hi everyone and welcome to our Polars tutorial series. In this series, we will explore how to handle and analyze data in Python using Polars, a high-performance data frame library built for speed and efficiency. If you have worked with Pandas before, but noticed performance issues when dealing with large datasets, you are going to love Polars. It's designed to handle big data with ease, fast, memory efficient, and ideal for modern data analytics. In this first episode, we will start by introducing what Polars is, why it is gaining popularity, and how it compares to Pandas. Then we will walk through our first hands-on example to create and work with a Polars data frame. Polars is written in Rust, which makes it extremely fast and memory efficient. Unlike Pandas, which runs on a single thread, Polars can parallelize operations across multiple CPU cores. It also has a lazy execution mode, which lets you define a data processing plan first and run it later. This optimizes queries and reduces memory usage. But don't worry if you are new to Polars. It has a Python-friendly API and looks similar to Pandas, so you can get started quickly. First, install Polars using pip. Pip install Polars. If you are on Windows, Linux, or Mac, the same command works. Once successfully installed, we are ready to import it. Before we get started working with data, we need to import the Polars library. Let's do that by writing import Polars as a PL. Here, we are importing Polars and giving it the alias PL. This short alias makes it easier to call Polars functions throughout your code. Now let's create our first Polars data frame. A data frame is a table of data made up of rows and columns, similar to what you see in Excel or Pandas. Here is a simple example. Here, we created a data frame with 3 columns, name, age, and region. When we print it, the data appears neatly in a table format. Notice how short and clear the code is. Creating a data frame in Polars is just as simple as in Pandas. Once you have created a data frame, it's important to explore and understand your data. Polars provides several helpful methods for this. You can use head to preview the first few rows. Then use dot shape to see how many rows and columns you have in the data. The dot D types to check column types and dot describe to view summary statistics for numeric data. Polars makes it quick and straightforward to understand your dataset right from the start. To work with real data, let's load a CSV file into Polars. In this example, we load a file named customers.csv, which contains thousands of records using read_csv function. Polars reads the file quickly and efficiently using read_csv. As we continue through the series, we will use this dataset to explore more advanced features. You'll also notice how much faster Polars is compared to Pandas when handling large datasets. Before diving deeper, it's a good idea to get a quick overview of your dataset. Here, we first print the column names to see what data we have in our dataset using dot columns. Then we check how many rows are in the dataset using dot shape in square bracket 0. Finally, we look for missing values by using is underscore null function combined with sum to count how many null entries each column contains. Polars expressions make this kind of column-wise operation simple and compact, perfect for quick data inspections. In this first episode, we introduced polars, explored the basics of data frames, and ran our first dataset example. Next time, we will dive into creating, selecting, and filtering data so you can start cleaning and transforming datasets efficiently. Remember, polars is fast, scalable, and perfect for both beginners and data professionals. Thanks for watching, and see you in the next episode.